So in this video, we're going to go over calculating definite integrals by using common geometric formulas. So it says compute the following definite integrals using formulas for common geometric figures. So here we have the integral from 1 to 5 of 3 dx. And the idea would be just to draw a picture of what that integral graph looks like. And then recognize that a definite integral is going to give you the signed area under the curve. And if the function you're working with is above the x-axis, that area will be positive. So the function f of x equals 3 is just a horizontal line. So it's going to pass through 3 like this. So this is f of x equals 3. And then if you're integrating over the closed interval from 1 to 5, what you want to recognize is that that's going to give you a rectangle. You want the area of that rectangle. What is the height of that rectangle? Well, the height of it is 3. And the width of it is 5 minus 1 is 4. So the area, the integral from 1 to 5 of 3 dx is just going to be the area of that rectangle, which has a width of 4 and a height of 3, which equals 12 square units. This one, we want the integral from 0 to 8 of 2x plus 4 dx. So this is a linear function, and that linear function has a y-intercept at 4 and a slope of 2. So it's going to look something along these lines. If we draw a picture of it, it's going to go up. And we're going from 0 to 8. And so out here at 8, we can find the ordered pair right here by just inputting 8 in there. So we have a function f of x equals 2x plus 4. So f of 8 is just 2 times 8 plus 4, which is 20. So we know the ordered pair here is 8, input 8, output 20. And right here, the ordered pair is input 4, and the y-intercept is at 4. Sorry, input 0, output 4. And the area under the curve between or over the interval from 0 to 8 is going to be the area underneath that line. And if we look at that, we want to notice it's just a trapezoid. And the area of a trapezoid is just the average height times the base. So we're going to get the integral from 0 to 8 of 2x plus 4 dx equaling the average height. So it's going to be 1/2 the sum of the heights. This height is 4 units high here. And the height over here is just the y-coordinate, which is 20. So it's going to be a half of 4 plus 20 times the base of that trapezoid is just 8 units. So times 8. So we're going to get 12 times 8, because we get half of 24. And 12 times 8 is just going to be 80 plus 16, which is 96 square units. So again, the idea is to not use the fundamental theorem of calculus if you know how to do it that way, but to rather draw a picture, look at the geometric figure that you get, and then use the formula for the area of that geometric figure to find the area of the integral, the definite integral that you're working with. So here, what I want to recognize is I have the square root of 36 minus x squared. This is actually, if we draw a picture of it, the upper half of a circle of radius 6. So it's going from -6 to 6, and the height is 6. So remember, the circle formula is going to look like x squared plus y squared equals the square of the radius. So if you see that you have a y squared equals r squared minus x squared form, you have here's a 6 squared minus x squared. And then if you take the square root, you always get plus or minus the square root. So if you eliminate the minus sign, you only get the upper half of the circle that you're working with. So I see that I have the this right here gives me the upper half of a circle of radius 6. So I see that the integral from -6 to 6 of the square root of 36 minus x squared dx is going to be half the area of a circle. And the area of a circle is pi times the square of the radius. Here the circle radius is 6 units. And so now we just calculate this. This is going to be 1/2 pi times 6 squared, so it's going to be a half of 36. 6 squared is 36 times pi, which is just going to be 18 pi square units.